Zach,
What's up?
can you hear him? I can hear him.
There we go. How about now? Is
Okay.
that better?
Yeah.
Oh, good. Swear it's one thing or another. Alright. Well, this will be like my last official lecture, if you will, today. After this point, we'll be spending more time doing like review. Well, really, we only have 4 more sessions, and one of those is the final. So we'll go over stuff today. I'm gonna show you guys a couple of websites as well. They're free, and it's just like information out there for you guys to be able to use. Today we're gonna look at a lot of the low voltage systems, like it says here in chapter 25, and the television, telephone, and low voltage signal systems. We'll also take a look at alarms, heat, smoke alarms, that kind of thing. And that kind of ties us up pretty much looking at everything, major and ordinary that goes into doing a house, at least from an electrical standpoint. But yeah, we'll start off today. We'll take a look here at chapter 25. What could be a low voltage signal system? Well, there's a few things. There's one common one that we'll point out here in a minute. A couple of like identifies here, if you will. What's a signaling circuit? And essentially, it's any electric circuit that energizes signaling equipment. And we'll identify what that is in a second here. Usually these are what they call a class 2 circuit, which is, it doesn't have open current really. It's limited to how much current it'll have. Sometimes you'll have like a little transformer feeding like the 120 volts, and that'll come something, I don't know, it'll be different low levels. It could be AC or DC as well. You could have like 120 volts step down to like 16 volts, 24 volts, that type of thing. But signaling equipment is anything that uses these devices like chimes, doorbells, buzzers. There's code calling systems and signal lights. And these all be things like associated with like the doorbell or alarm systems, that kind of thing. And they use a low voltage. They're not usually run on the 120. Usually you'll have the 120 fed into somewhere feeding one of these little guys. And this is just a very standard doorbell transformer for chimes and buzzers, that kind of thing. They're generally rated at 16 volts. They should be listed as class 2 because they do have a current limit. See, a lot of times when you go through these things and you have a transformer and you go and, let's say I have 120 volts being fed in and 16 volts coming out, it creates a ratio. And a lot of times, if the voltage is going down, what will happen is you'll get current going up. Well, in this case, we don't do that. They, again, for fire prevention. So these little off-the-shelf transformers are, they keep the current to a low, and the voltage down to a low. And this illustration here is kind of a common configuration. And what you usually have is on pretty much a standard doorbell type. You'll have both a front and a rear capability to it. So you could have as you can see from here, these are the buttons themselves, doorbells. So you could have one like out at the rear, the back door, the garage door, that kind of thing, and then one at the front door as well. And basically what it'll do is you press the button, it creates a signal, completing the circuit for the transformer, and then the transformer would go ahead and make some kind of chime or bell or whatever kind of device you have hooked up, it'll make that kind of noise. But this is a very simple one, and you'll notice it just has a front connection, a rear connection, and then what they call a transformer connection. So that way, when you press the button, it completes the circuit and you get some kind of action going on here. So this transformer won't be constantly energized. And these things are always located in an oddball spot. You'll have it somewhere up in a crawl space or like in some closet somewhere tucked up in the corner, wherever your doorbell happens to be. You generally don't see the transformer. So you'll have like this, and it's small wire as well. Generally, only pulling like number 18. They even sell it in coils where you would have like doorbell wire and it'd already be in a twisted pair all set for you. Um, let's see what we have here next. And this is a very common circuit showing how this is laid out. So you'd have the 120 volt line coming in from your service panel, going to that little transformer, and it steps it down to 16 volts. And again, this is split up so that way you have the buzzer or chime connected to the push button, and the circuit isn't completed until, of course, you push the button. And then every time you push the button, the buzzer should sound as long as all the circuitry is working correctly. You'll notice it has its own little separate overcurrent protection, right? There's its own little circuit breaker right here, neutral line, neutral bar. But that's a pretty common layout. I mean, there's always going to be variations to this depending on what you're looking at. In this day and age, doorbells come in so many different shapes and sizes. You could have a totally different size transformer and that kind of thing. It all depends on what you purchase. That's a very standard, very typical, and relatively cheap. Those transformers really don't cost very much money. In general, you can go to some supply house and they'll just be a few bucks off the shelf. So it's always easy to change them out if they go bad. But anyway, so now we look at, we'll go ahead and take a look at chapter 26 here, where smoke, heat, carbon monoxide, and security system, which are becoming a lot more popular these days, and a lot of variations to them too, all depending. But for smoke alarms, we have, notice it has National Fire Alarm Code, right? This is not quoted from the NEC, but another area, NFPA 72. So this would be a separate section, and this actually has its own publication, National Fire Alarm Code and what's allowed and not allowed, that type of thing. These days, smoke alarms are considered the primary means of protection against fire in the homes. It's your first line of defense if something were to go wrong. Who knows? Cooking fires, something in your utility room, God knows what. But these are the takeaway terms from this chapter. Pretty much, know what an alarm is, what is a heat versus a smoke alarm, you got what a detector is, heat versus smoke detectors, household fire alarm system. And that's an interesting one. You could have a few different types of things, and they're all connected on one line type system, so there's no break in it. And if any one alarm senses something, it'll fire off all alarms, so that way they all go off all together and not just the one isolated one. There's these days combination detectors where you could have a few built-ins into your alarm system, depending on what you purchased. There's single versus multiple station alarms, where you could have several things going on. And this is more popular with like home systems. Like ADT is very popular with selling like a home alarm system. Well, when they do this, they also incorporate, depending on what you purchase as far as a package, they offer like theft protection, your windows and doors, if you will. But they also have a system where it'll tie into like your smoke alarm, carbon monoxide detection, heat detection, and all that kind of thing can all be tied in with a centralized station as well. And it all comes down to what you want to spend, that type of thing. Know what a dwelling unit is, a living area, and separate sleeping areas. And again, it depends. These all are important because of how NFPA 72 treats it. So your sleeping areas have to be protected, as well as certain portions of your living area and what is considered your dwelling unit. So these are all important terms that come away out of this chapter here, chapter 26. Would be, if any of you know any of the terms from that chapter, this would be what you would want to basically focus on. So what do? Well, we got smoke, heat, and carbon monoxide alarms. They generally give the occupants of the dwelling early warnings of fire or toxic fumes. You know, in the case of carbon monoxide, maybe your water heater all of a sudden for some reason isn't working correctly or discharging the fumes. Who knows? A bird built a nest into your exhaust or something like that, and you're getting back in. The carbon monoxide alarm will detect that. Because the bad thing about carbon monoxide, you know, it's odorless and it's a silent, deadly killer. Um, excuse me. But the home types, you know, of course, they do sell, you know, different varieties of systems depending on where you're at, what you're trying to protect, how much area you're trying to protect, and that kind of thing. But the general home types for smoke, heat, and carbon monoxide devices can usually contain, they'll have the detector as well as the alarm in a single system. Now you get into industrial settings, you might have detectors all throughout, and then that'll alert like a central system, and that'll allow lights and sirens to go up, and that would be, you know, separate systems. But in this case, usually your home style systems will usually be a duality type where it has the detector and the alarm built in one unit. So, what are some of our rules? So again, go back, we're referring to NFPA 72 here. Um, if you install in a brand new construction, now you have to consider that every single detector has to have two power supplies, essentially. The home system, which is your 120 volts. So now you're going to go through and make a separate branch circuit up for your alarm system, you know, for its own overcurrent protection and everything else. And these will actually have outlet boxes installed and everything for them. Now, it used to be when these first came out, they just had battery backup, and essentially you had two screws. Will you shut up? Hold on a second. Oh. Sorry. Oh, but yeah, they would have just a battery to it, you know, just a little 9-volt transistor battery. But any new installation these days, yeah, you'll be pulling in your own separate line and everything. You have an outlet box where the detector is going to go, and it'll be hardwired in, and of course battery backup in the event that power fails, that still the alarms will still be working. So, and the reason being, these days they have an interconnection requirement. So that way, if one alarm somewhere throughout the house goes off, it'll alert all the other alarms. So that way you have, you know, your sirens going off or your buzzers or whatever noise that happens to be going with this thing will be firing off throughout the house. Yeah, the new construction, you have like some, you know, certain alarms, they had like plugins because you couldn't be, you know, tear your house apart and install new outlet boxes. So they had like a little adapter unit where you could plug in and still have that way you would have line voltage as well as a battery backup to it. But they are not allowed on new construction sites. You know, it's something where if your home's already built, it's something that you can build in. And then there's always, of course, the hearing impaired options for these alarms where they have some kind of really bright strobe to it that can't be ignored. something that'll wake you up while you're sleeping kind of thing. And so these would have to be installed, of course, in bedrooms and then in the locations throughout the house that was required. So what do we got here? Wireless systems these days, and it's becoming quite popular actually, more and more with the Wi-Fi systems, getting away from any hardwired USB requirements or anything like that. It generally works with your home router. And yeah, like I said, these are becoming a lot more popular. Heck, you can even get your fridge and stove can be Wi-Fi now these days. But for alarms, they have to be interconnected. If it's a wireless system that's essentially using some type of Wi-Fi going back to a central unit, still has to be set up so that when one sounds off, they all sound off. They do have to adhere to this standard. The Underwriters does have its own set of standards, and in this case, it would be standard 217, where they call for what the standards are for single and multiple station smoke alarms. So when you buy these things, this is the label you would want on your package would be this one here. Underwriter standard 217, so that way it's compliant. 120 volt AC powered, of course, and then battery backup as well. But yeah, these systems are fairly easy to install. That way you don't have to have like a signal wire running to each one to interconnect them. They're just wireless little Wi-Fi capabilities to them. And this is how you would basically, this is not showing room to room, of course, right? But essentially we would have a 120 volt circuit and see how they're all fed in. And then you have your shared line here. Notice that red wire. Yeah, that red wire is your interconnection. So that way, if one of them goes off, they all go off. The black and white wires here are just your line voltage. So you got the white for the neutral and the black for the hot. But that red wire is basically your interconnectivity to all the alarms. So depending on how many you have in your home or apartment or whatnot, these would all have to be connected through. And of course, you have to run these wires throughout. So what kind of smoke alarms do we got out there? Well, we got photoelectric styles, right, where a light sensor measures the amount of light in the chamber. And that'd be like the sensor itself. And then they have the ionization type where it has a slight radioactivity to it that ionizes the air, which causes the current to flow. So as long as everything's operating normally, this dial here has a little chamber to it, and as long as there's no blockage, it continues on as if no problem. But the minute you get denser stuff like smoke into it or something like that, it'll block the chamber, and in which case it'll just start turning off the system. Of course, this is much more reliable than going with the photoelectric type. And then we got the heat alarms, right, where it's a fixed temperature. It'll sense a specific, fixed temperature, what's your normal operating range and everything. And it'll notice rapid changes in temperature. So in the case like a fire where you're going literally from like, let's say 75 degrees all the way up to 100 or over, immediately it'll notice that, in which case it'll sense, oh, there's a big change. Slow changes, like if you go from 75 to 80 degrees, maybe you turn the air conditioner up or something like that, that won't affect it. This looks more for like a quick change within minutes of the temperature going up. And you can get these things with different features actually. See here we got this heat alarm, right, where it's a fixed, radarized, or smoke. It's all available in one unit. And then you get the fixed, radarized available as a combo unit. So depending on what your needs are, what you're spending and whatnot, will decide what type of devices you could get. You would almost think getting one where it's like this, right, where you get the radarized protection, so rapid changes in temperature, and then a fixed temperature if it goes up and over that, and smoke detection all in one unit. You'd be pretty well covered. Probably be a little bit more expensive, but again, it'll take up less space. It's up to the homeowner. You could end up installing either one or both. Uh, and so here's our minimal. Now you can always install extra smoke alarms. There's nothing against that. Um, but as far as like the NFPA is concerned, these are the areas that absolutely have to be covered. There's got to be coverage, within the radius by this alarm for these different things. So you can see pretty much, right, all sleeping areas, guest bedrooms, basically anywhere where anybody's going to be sleeping, you want an alarm protecting it. um, all levels of the residence, depending if you got like a basement and the first floor, if you got a second floor, that kind of thing. So you have to look at it as each level has to have some kind of protection to it, even if there are no sleeping areas on that level. Let's say all the sleeping areas are up on the second floor and everything else is on the first floor, you would still have to have the first floor protected. And granted, you will probably have a lot more on the second floor if that's where your sleeping areas are, and vice versa. Hopefully that helps. But yeah, and you can always go over. You can always go over. There's nothing against overkill. There is against underkill. Like I say, you have to have all the sleeping areas protected, each floor, that kind of thing. And they have requirements as far as like where it can be installed. You can't put it in certain areas where the smoke wouldn't be going to, heat wouldn't go to, that kind of thing. So they take away and we would call common sense, right? And we just specify, okay, don't have it here and don't have it here, that kind of thing. How far up from the ceiling can it be? So if you install it on a wall, it can't be not further away than 12 inches and not closer than 4 inches to the ceiling. And the same with like a flat ceiling, right? And no closer than 4 inches from the adjoining wall. Because if you get in a corner, you kind of make that corner can be like a dead space area, literally where the smoke would like flow around it. So you kind of want to get it out of the corner and into more of the general area is kind of the rule of thumb here. And the same if you got like the vaulted ceilings, right? Peak ceilings has to be within 36 inches from the peak, if you will, and the same with slope ceilings. I'll give you a little picture here. So here's a kind of a standard layout. Now notice, okay, each bedroom has a smoke alarm, and right outside the bedrooms, there's a smoke alarm right in that hallway. So that way you're protected for your sleeping areas and your living areas as well. And now here is the placements. So if we look at a standard room here, right, just a box, if you will, you'll notice that one, right, you cannot go into the corner itself. And that's your kind of your rule of thumb. You want to get out of the corners. And the same with like even the vaulted pitch ones here, right? You don't want to put it into the peak there. You kind of want it off and away. Notice it's further down. And then and see how they did here for the separate floors. They kind of went and covered each stairwell, if you will, and in the center of the like the living area or something like that. So this would be pretty much a general layout, like a standard approach, for the placements of all the different alarms, if you will. Basically, a rule of thumb is avoid areas with dead space, like in corners or peaks, that type of thing. And there's a little blow up. It shows you, like, see, this whole red triangle is you cannot install there. Now you could have a smoke alarm anywhere within the wall here, right, from 4 to 12 inches. And the same if it's on the ceiling. It could be anywhere within the ceiling. It just cannot be within 4 inches of that corner. That's the way you would want to look at that. And the same if we have like a peak area, right? Keep it out of the peaks, put it more down to here, and get out of that whole like dead zone area there. And the same with the last one, or if we just have like a slope ceiling that has only the one peak style. Again, 36 inches to it, right? Pretty much go and install in this area here to keep it up and high, but not too high. And here we go. So what's our requirements? Well, so NFPA 72 says that every month you're supposed to go through and basically look at the alarm and then push the test button. make sure it fires up okay, the battery's still good and that type of thing. You can go and refer to the manufacturer's instructions and make sure you're testing it correctly, that they have any special requirements or anything like that. And a rule of thumb is replace the smoke alarms when they fail to respond to tests or if they're over 10 years old. Because basically the detectors age with time and they become more unreliable as you go along. And so they've generally found that after pretty much 10 years of service, just from normal wear and tear, it could end up getting like, a certain amount of film on it from, just background dirt over the years, that kind of thing. So the rule of thumb is if it's over the 10 years old, replace it. And make sure we test them monthly and replace them when they fail. Now, carbon monoxide alarms are a little different. They're generally not installed all over the house and whatnot. They're meant to stay wherever you're having gas fired off. More than typically, it'd be like in the utility room where you're going to have like your hot water tank and your furnace. If you have a gas furnace. So if anything were to happen, that the gas isn't burning correctly or something like that, you would want to have a carbon monoxide detector in place, just in case something were to go wrong. So if you do have these, you install them in at least one in each home outside of the individual bedrooms, right? Protecting you again while you're sleeping. You want them to have an early warning before we get the gases built up to a dangerous level. And then NFPA 720 contains installation recommendations, very similar to the smoke alarms. Again, avoiding, bad install areas, that kind of thing. And then if we looked at fire alarm systems, now this would be a whole complete system that generally has some kind of like brain to it. You'll have like a centralized like control unit or something like that. ADT is popular with selling these type of systems, as well as like the home protection systems. But requirements for these are covered in the NECs. This actually goes back to the NEC. We're looking, and in this case, we haven't gotten back into this. This will be way back in section 7, right? It's 760.2. So some of the things to highlight here. So fire alarm circuits can either be classified as non-power limited or power limited, depending on the type it is. You would have to go back and see the equipment that you're dealing with here and what you paid for and that type of thing. But yeah, it's controlled by the fire alarm system. Like I say, it'd be like a central brain that controls the whole system, and it's all wired as one unit coming back. So they would have their own leg, right? So they'd have their own overcurrent device, and they are required to be wired a certain way. Right? Everything from the load side, the hot side, if you will. It can connect and control and go all the way up through and feed that brain system, if you will. It's generally like a little control box. It might have like, these days it depends. They'll have probably some kind of display on it where you would have to enter in codes and identify each alarm system. Generally, when you buy these, you can buy them at, from supply houses, even Home Depot and that kind of thing, as a one unit type thing, and install them yourself. Or you could buy a system from like ADT or one of those big companies like that, and they also have those. But that covers pretty much it. What I do want to show you guys, I got a couple of things here. There we go. I know this was a boring one today, but I might have shown you guys this website before, but just in case. So this is NFPA's website. And when you first go in, it kind of shows you, codes and standards, and you're able to browse through and see all that different areas NFPA gets involved with. And you can take a look at these depending on what trade you're dealing with and stuff like that. And you notice though, basically anywhere in the 70s, okay, so NFPA 70 starts it with the National Electric Code, right? And then you get breakdowns from that depending on what you're dealing with. The one we just looked at a second ago, see, NFPA 72 has its own national fire alarm and signaling code, and they have their own set of standards right there. And it breaks down depending, there's even, let's see, NFPA 79. Say if you get out there and you're dealing with like an industrial factory or something like that, and you deal with industrial machinery on a regular basis, you might want to start taking a look at NFPA 79 standards and stuff like that too. That'll help you out. But these are all free. All you're really required to do is go in and set up a profile, and you can't download the documents per se, but you can pull them up in like a PDF format and look at them. And of course, you're always able to buy the books from here. It depends on what they are, but like the NEC itself is like $95 for the book, and you can get that a hard copy, actual physical copy or an electronic copy. It's the same price either way. But yeah, you could get the NEC if you'd want, or buy any of these other publications. But if you create a profile and you go in, you're allowed to go ahead and look. Like in this case, if I looked at the National Electric Code, we can't view this document. So if I did want to look up stuff that was in the NEC and I didn't have a book available to me, I am able to pull this up and actually research stuff in there if I wanted to. But that's a freebie site. I mean, there's nothing wrong with going on and setting yourself up, if you will. I also want to show you another website, one of my personal favorites. Hold on here. Wrong one. Now this website is called EC&M. Oh, good word. EC&M, and what it is electrical construction and maintenance. So it kind of, I mean, if you're going to be involved with electrical, this one here has a lot of, oh my God, they have so much stuff. And it's related to basically the electrical trade, whether you're in construction and whatnot, or if you're doing like electrical maintenance, depending. But this covers basically both sides. You're able to look up, you can go through, and again, you register and it's free. But they have a lot of articles from anywhere from beginning to advanced, from like good illustrations on how to properly wire stuff up. Even if you have any questions, they do monthly code challenges. See here, like code quiz of the week, right? It's like, okay, go through and identify and see if you can spot the code violation. And you email it in, and you actually get prizes. They a lot of times give out like power tools and stuff like that, which is kind of cool. But yeah, EC&M, it's a free website, but like I say, they got a ton of articles. They're always coming up with new stuff, staying on top of what's out there in the field, what's changing, that kind of thing, which is kind of nice. So, yep, those are my two websites I like to give out. And also, let's go through. Oh, here. I got one other thing for you guys today. Hopefully this comes through okay. But if you go on day 13's tab here, you'll see an area called Teach Back Review Materials. And then you go in there and you got a bunch of review documents. Now, basically, these are all set up for for the final. So if you want to go through, and there's like some problems to it and stuff like that, and general information. And this is basically your whole, if you want to get a sneak peek and quick preview into what the final is going to have on it, and you go through all those, I can promise you that you should be able to pass. And if not, you'll notice that there's another, well, I got the two websites that I just went over on there as well, but there's another tab here called Final Review. And you'll see it's Electk 111 Final Review. And when you pull that up, now that's just one, well, it's a couple of pages, but it's just a Word document. Here, I'll pull this up for us. Let me see if I can share this. There we go. So this is what I call a final cheat sheet. It's 2 pages, but it's all got basically some statements or even a couple of questions on here, right? Things to know. This would be like things to know for the final, like arc flash can create temperatures 35,000 degrees Fahrenheit and up. What the NEC is, in this case, the minimum safety standard, right? Then a question like, okay, what is an AHJ? Okay. And these are things that basically like a takeaways from everything we've learned so far. So what's an AHJ? And that's authority having jurisdiction. And that might be on the final. And then let's see, and it's like even hints right here. So what's the meaning of approved is acceptable to the AHJ? Voltage across the switch, you know, that kind of thing. And I give this out now so that way when we meet on Wednesday, if you guys have any questions, you know, you can email me some questions or just come on here and ask, and we can go over anything that might not be clear, might be confusing. But yeah, if there's a, go through and look at this cheat sheet, and then if you look through and like I say, you look through those exercises. But that's what I have for today. So yeah, we did chapter 25 and 26, and no, there's no homework for it. That was just simply a need to know or a coverage of like doorbell systems and things like that. But yeah, take a look at these websites. I mean, if you will, the NFPA one is nice. You can get, like I say, you get free access to it. Go on and look at all their publications. So if you do end up even getting involved in like a different trade where it's not electrical and you want to find out what kind of things NFPA might have for that, you can go through and look and see that as well. Like they say, knowledge at your fingertips. But that's pretty much what I have for you guys today. And then and I am going through and I will have everything grade wise posted today. Got through, I graded everything, so now I just got to post all your grades for it and we should be all caught up. And like I say, start reviewing the stuff for the final, and that way if you have any questions, you know, we can go over it. But we got Wednesday and then we got Monday as well, where I'm not oh, and on Wednesday I'm going to be posting 2 extra credit assignments. So if anybody feels that they want to extra credit or something like that, one is like an Ugly's book quiz kind of extra credit, if you will, on safety. And then the other one will probably be like some kind of code challenge where I'll show you a picture and you get to identify what the code violation is and send me your answer. And then, yeah, that'll be like extra credit in case you feel like you need some extra credit. And that way it'll give you a week to go through it and do it. And then that way by next Monday, then we can go over everything for the final and all that. But that should about do it really for today. I mean, that's pretty much it from the start to the finish at this point. We've covered pretty much all the major points of a house, the housing systems that we would need. And so now we just kind of go through and review all the crap we went through really, really fast and make sure you learned it. And then, but usually everybody does pretty good on the final. So, you know, I don't believe in like trick or surprise questions or anything like that. I feel like, you know, if you know this information, then you know it. But yeah, that's about it for today.
All right.
Like I say, you know, I know since there's no assignment, if you get bored, take a look. Like I say, take a look at those that teach back review, exercises and stuff, and then look at the final review. And if you have any questions on that, then let me know, and we'll go over that on Wednesday. All righty.
Yes, sir.
All right. Well, you guys have a great day.
You too.
I will see you all on Wednesday, bright and
Okay.
early. No.
Okay.